You have done it thousands of times without thinking about it. You pick up a bottle, hook a bottle opener under the cap, pop it off, and move on with your life. But look at that cap before you set it down. Running around its entire edge is a series of small, precisely spaced ridges, folded outward like the points of a tiny crown. Count them and you will almost always arrive at the same number. 21. Not 20. Not 24. 21, consistently, on nearly every standard beer bottle cap produced anywhere in the world for the last 100 years. That kind of consistency, maintained across different countries, different manufacturers, and different decades, does not happen by accident. It happens because someone, at some point, worked out that 21 was the right number. And the story of how that conclusion was reached turns out to be far more interesting than the cap itself would ever suggest. To understand why the bottle cap exists at all, you have to go back to the late 19th century, when bottled beverages were becoming commercially significant for the first time. Breweries and soft drink manufacturers were producing drinks in large quantities and shipping them by rail to customers who might be hundreds of kilometers away. That created a sealing problem that nobody had adequately solved. The dominant closure at the time was the cork. Corks had worked well enough for wine for centuries, but carbonated beverages presented a different challenge entirely. Internal pressure from dissolved carbon dioxide pushed constantly against whatever was holding the bottle shut. Corks dried out. They leaked. They occasionally failed catastrophically. Other stoppers of the era had their own shortcomings. What the industry needed was a closure that was cheap enough to use on every bottle, reliable enough to hold carbonation across long journeys in varying temperatures, and simple enough to manufacture and apply at the speeds an industrial bottling operation required. That solution arrived in 1892, when an American inventor named William Painter filed a patent for what he called the crown cork. Rather than plugging the bottle from above, Painter's design placed a thin metal disc lined with a sealing material over the mouth of the bottle and then crimped the edges of that disc tightly around a specially shaped lip on the glass. The result was an airtight mechanical seal that held carbonation reliably, cost almost nothing to produce, and could be applied by machine at high speed. It was so effective that the fundamental design has remained essentially unchanged for over a century. The ridges running around the edge of a crown cap are called corrugations, and their purpose is almost entirely structural rather than decorative. When a crown cap is applied to a bottle, the sealing machine does not simply press it flat against the glass. It folds each corrugation inward and downward, crimping the metal tightly beneath the lip of the bottle in a series of small, evenly distributed mechanical locks. The corrugations are what make this crimping possible. A smooth-edged disc of the same metal would buckle unpredictably under the crimping force. Without the corrugations to guide how the metal deforms, the cap would wrinkle unevenly, creating gaps where the liner fails to make consistent contact with the glass. Those gaps are where carbonation escapes and where contamination enters. The corrugations ensure that the deformation during crimping happens in a controlled, predictable pattern distributed evenly around the entire circumference of the bottle's lip. Each ridge folds into a specific position, and together they form a seal that applies consistent pressure all the way around. The liner material inside the cap, which in modern production is typically a thin disc of low-density polyethylene rather than the original cork, does the actual sealing work by compressing against the glass. But the corrugations are what hold it there under the internal pressure of a carbonated drink. The number of corrugations is not arbitrary, but it is also not the result of a single elegant mathematical insight. It is the result of practical engineering optimization carried out over decades of industrial experience with a specific cap diameter. The standard crown cap used on most beer bottles worldwide has a diameter of approximately 26 millimeters across the opening. At that diameter, the number of corrugations determines the width of each individual ridge. Too few corrugations and each ridge becomes wide, making the metal more difficult to crimp evenly because each fold covers more material. The sealing machine has to work harder to deform the metal consistently, and at the speeds modern bottling lines operate, inconsistency becomes defects. Too many corrugations and each ridge becomes narrow, which creates its own manufacturing challenges. The metal between each ridge is thinner and more prone to tearing during the crimping process. Quality control becomes harder to maintain. 21 corrugations at the standard 26mm diameter lands in the precise middle of these competing constraints. Each ridge is wide enough to crimp cleanly and narrow enough that the total number distributes force evenly around the full circumference. The sealing machines designed around this specification can run at tens of thousands of bottles per hour while maintaining consistent seal integrity across every single cap. When that performance was demonstrated to be reliable and reproducible, it became the industry standard. And once it became the industry standard, the entire infrastructure of bottling, the machines, the quality control parameters, the bottle opener designs, and the glass bottle lips themselves all converged around it. That convergence is why 21 has persisted for so long. Changing the number would not just mean changing the cap. It would mean changing the machines that apply the caps, the bottles the caps fit onto, the openers designed to remove them, and the quality specifications used to verify every seal across every production line in every brewery using that format. The cost of that change has never been justified because the existing standard already works essentially perfectly. The bottle cap is one of those designs that succeeded so completely that it became invisible. You use it every time you open a bottle and never think about it, which is precisely the measure of how well it works. 21 ridges, folded under a glass lip, holding back the pressure of carbonation, unchanged in its fundamentals since 1892. Sometimes the best engineering is the kind that disappears entirely into ordinary life.